Okay, looks like we're recording now. I will go ahead and start sharing my screen and we'll get started. All right. Are there any questions from last time before I kind of jump into some new material? Okay. Okay. Well, let me go ahead and make a new script. Clear, close all CLC. That's how I like to get started. Okay. Last time we talked about different vectors and how to create vectors, how to create arrays, different things like that. Today, what I'd like to talk about is plotting, functions and plotting, to be more precise. So with functions, we've talked a bit about this. In the last lecture, we sort of used some functions. There are other functions. Actually, most of what you can do in Matlab is with functions. So I want to just talk about them a bit. So some example functions would be something like round. So if you have some value, let's say 4.5, and let's store it in x. So we'll say x equals 4.5. Wait, let me make my font bigger so you can see. Maybe that's a little too big. Okay, so we say x is 4.5. We want to round. So we want to round x. We just say round x. And we see the answer there. Of course, we can store that into another variable, round x. What you'll notice when you type in round and just open the parentheses is that you'll see some various inputs you can have into that function. So you could have x and n, or you could just have x, or you could have x and n and type. Let's say I have no idea what those things mean. You can type help round. You can type help and anything and it will show you. So here, this a little wider, it explains. So round x rounds each element of x to the nearest integer. Round x n, for positive integers n, rounds to n digits to the right of the decimal point. So if, for example, you had x equals 4.56789, round of x gives you just 5, round x comma 1, which is that n there, x comma 1, gives you 4.6. Okay, so it rounded to 1 decimal place, 2 decimal places, 3 decimal places, and so on. All right, so you could just keep following this through. in whatever way you want. Okay, so there are lots of different functions. Generally, you type the function name, you open parentheses, you have some input, any number of inputs, then you close parentheses. That function will output a particular thing. So you store it into a variable, or you can just hold it for display. So another example is cosine. Cosine of 2 pi is 1. Cosine of 0 is 1. Now, something helpful to know here in MATLAB is that cosine, it works in radians. So that's why I'd said 2 pi. Cosine of pi, -1. If you want to do it in degrees, you say cos d. For degrees, you could say cos d of 180, -1. Cos d of 90, 0, and so on. Okay, round is an example of a function that works with arrays also. So let's say you have x is equal to 1.2. We want to step by 0.2 all the way to 3. Okay, so here's x. You can see it. We want to round x. There it is. So it's just this rounded. I added the apostrophe to make it easier to see. Transposed the array. Of course, cosine could also work like that. So you could say cosine of x. Transpose it. Here's cosine of x. So this leads us into plotting. It's kind of leading us into plotting. So let's say that we want to plot y equals cosine of x. We want to plot on the x-axis from 0 to 2 pi. From 0 to 2 pi. Well, first, we need to know how to, we need to have 2 arrays. Okay, so when we plot something, we need to have 2 arrays. We need to have the x values of our array of each point in the line and the y value of each point in the line. I see a hand raised. Sarah?
Yes, doctor, can you repeat how did you turn x into a matrix or a vector?
Yeah, sure. So I just typed here to create a vector. So remember, there are a few ways to create vectors. I just created kind of a random one. I started at 1.1 or whatever it was. I stepped by 0.2 all the way until I got to 3. Okay, so there it is. Let me do this again. Okay, so there it's all in one screen. That's one way to create a vector. Does anyone remember the other way to create a vector? Can you type it into the chat? So this is the way, we just showed the way using the colon. There's a function we can use to create a vector. It's called Linspace. Good, someone's close. Linspace. So it's lin for linear. These are linearly spaced, which means there's equal distance between the points. So what's the input? Well, we could just let MATLAB help us. This would be our low value, our high value, and then how I usually use it is with a third value. That's the number of elements you want in that array. So if we want to say linspace 1.1 to 3, let's say we want 5 elements. Okay, 1, 2, 3, 4, 5. All of these are linearly spaced, which means the difference between the first element to the second element is the same as the difference between the second element and the third element. Okay, so here there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. Oops. So we could just retype linspace, but here instead of 5, we say 10. It's going to give us the exact same as this one. Actually, no, it's not exactly the same because our final value here was 2.9. If we change this to 2.9, then it would be the same. Okay, so back to plotting. When we plot, we need 2 vectors. So we're going to, the command we're going to use is plot x comma y. Plot x comma y. X needs to be all of the x values of each point in the line we want to plot, and y are the corresponding y values. Of course, when you plot something, we're basically plotting a scatter plot. So we're going to plot all of the points like 1, 2, and then the next point we plot would be 2, 3, and the next point 3, 4, something like this, right? So these are our XY coordinates, but we're not going to enter it into the plotting command like this. We're going to enter it something like this. So we'll have X first. So let's say 1, 2, 3. And then our Y values that correspond to these X locations, 2, 3, 4. Press enter and our plot comes up. Okay. Great. So what you can see on this plot, you can see the individual points. On the x-axis down here, you see 1, 2, 3. It goes all the way from 1, 2, and 3. On the y-axis, it goes from 3 to 4. All of these points are on here. So we can show those points individually. Actually, what we can do is just put a comma and star. Okay, so now we've changed how we want to display these points. It's hard to see, isn't it? Can you see these points? See the star? Okay, good. So there's a star here at the value 1, 2, a star at the value 2, 3, and a star at the value 3, 4. And so that's what we see: 1, 2, 2, 3, and 3, 4. And we used a star to mark them. If we don't use a star, it's just going to automatically connect those values. See, so they're just connected. Now, let's say we want to plot cosine of x when x is, we want to see the range from 0 to 2 pi, from 0 to 2 pi. So in order to do that, we need two vectors. Let's say I want to type plot xy. What should x be and what should y be? Could you type it in the chat? What should x be and what should y be? Let's just start with x. What should x be? Okay, let's see one answer.
I didn't get your question.
Sorry, can you say that again?
I didn't get the question.
Okay, good. So thanks for clarifying. So what we want is to see a plot of x and y. So let me see. Can I maybe? Okay, so this is what I want the plot to look like. So here's our y-axis. And here's our x-axis. I want to plot from 0 to 2 pi. So let's say that this point is 0 on the y-axis. This is 0 on the x-axis. And here is 2 pi. I'll have to forgive my handwriting here. It's even worse than normal. I have to try that another time. Okay, so if this is 0 on the y-axis, what we want to see, of course, we know that at 0, cosine of 0 is 1, cosine of 2 pi is 1, cosine of pi is -1, 0 there, and 0 there. Okay, so it should look something like this. That's what we want to see. Okay, so the question now is, when we're plotting in Matlab, what should be the x vector and what should be the y vector? Okay, so you can type your answers in the chat. I'm looking at the chat on my iPad, so I see what you're typing, even though it's not pulled up right here. Okay. So I see a few answers. So in order to answer this question, you have to consider yourself. You have to ask yourself a different question also, okay? And that other question is, well, how many values do I want? Because I could plot 2 values, okay? And then I would just have these lines. So I'd have this point and this point, and MATLAB would just connect them and I'd have a line. That's what it would look like. All right, just a straight line. That's not what we want. Okay, well, let's say I added a few more points. Okay, I added this one and this one and this one. So here's a total of 1, 2, 3, 4, 5 points. Well, what would MATLAB draw? It would look something like this. Be connected to there and then to there, straight line to there, and then a straight line to there. All right, that is also not really cosine. It's not cosine. Okay, good. So I see someone typed maybe use Linspace. That is a good idea. So if we used Linspace, we're going to say we want to go from 0 all the way to 2 pi, from 0 to 2 pi. With Linspace, we get to say how many points we want between 0 and 2 pi. So how many is enough, you think, to show the general shape of cosine? Well, we could try different amounts. So let's say first x equals Linspace. I want to go from 0 to 2 pi. And let's say we want 100 points. What will the y values be? How can we calculate y? Remember, y we said is cosine of x. So how can we create the vector for y? Any answers? Okay, you're right. It will be on the range between -1 and 1, but we want to let Matlab do the calculations. So all we have to type here is cosine of x. That's right, cosine of x. Okay, so now let's plot x comma y. See the answers? There it is. Okay. So all of the points have been connected. We didn't show the individual points, but we can do that. We can show all the points. Just add the star here. Okay, and there you see all of the individual points. So these are just connected with a straight line by Matlab. So let's go back and sort of ask our other question. If, let's say we used, instead of 100 points, we used 10 points, and we need to recalculate y, and then we can replot x and y, see what it looks like. Okay, well now it looks a little choppier. You see, you can kind of see the individual points. Let's add in the stars. Okay. So it's just not as smooth. It's just not as smooth. So generally, it totally depends on your signal, but for something smooth like cosine of x, 100 works, at least on this scale, from 0 to 2 pi. Okay. So let's talk about how to make this plot look better. As engineers, you know, or at least I hope you know, that you always label your axes on a chart. Okay, you always label your axes on a chart, on a plot. So if you're going to label your axes here, how you can do it is by using some commands. So you have your figure open. What you need to type here is X label, okay, open parentheses, and then you have a single apostrophe here, and then a single apostrophe to end it, and then a closed parentheses. So what you type in here will be the X label. Here, I'm just going to type in X. All right, so you see the X appeared in the plot right there. Now, let's change our Y label. Our Y label, we want to be cosine of X. Right, there it is, cosine of X. And then the final thing that could be helpful is just to give it a title. Our title can be Y equals cosine of X.
Yeah.
Is there a question? X label, Y label, title. These are all very helpful and necessary plotting tools. Okay, there are some other things that you can control. So we've talked about plotting with a star and without anything, okay? Notice when I redid this plot, the X label and the Y label and the title went away because I plotted something new. But let's do this. We have X and Y. We could do the star and the line together. It looks like this. Okay, so it's a star and a dash. There are a bunch of different combinations. You could type a S and it changes the symbol to a square. You could type 2 dashes and instead of doing a straight line, it does a dotted or a dashed line. You could do a dash dot. Okay, this changes the type of line from a line to a dash dot line. I think you can do dot dot. No, you can't. I have a hard time remembering what exactly you can do sometimes. But a good way to figure it out, and I use this all the time, is to go to the MathWorks website. So the MathWorks website, you can type, actually do that. Let's do this. I usually just type Matlab Plotting. You can look at different colors. You can look at whatever. So here, control how plotting functions. Yeah, okay, this is what I'm looking for. So different things you can do. You can change the color. You can change the line style. All different kinds of things. So you can see here all the different types. This is not the chart I'm looking for. Okay, so here are some, you can change, you can use the color. So here you could say plot XY and then red. Okay, so the color here is red now. You could type any of these colors, red, green, blue, cyan, magenta, yellow, black, white. You could also use these shorter names and symbols. So that would look like this. R, or you could say G for green. You barely see that, but it's green. Or you could use the RGB value or the hexadecimal code. Okay, so let's say we want it to be magenta. We could use this hexadecimal code. I didn't do that quite right. Actually, I never do that, so I always just use this. Sure, it shows an example. All right, this is a different type of plot, bar plot. We're just talking about scatter plots right now. Okay. Matlab line styles. Again, MathWorks website is the place to go for this. It's very helpful. So here are the 4 different types. I knew I had it. I was close. It's not 2 periods. It's a colon. Okay, so you could say red and like this. Oops, I think I have that backwards. No, you put them together. So colon R, like this. So that gives us a dotted line that's red. A dotted line that's red. Here they have the example of dash, 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 O. Okay, so these are each of the data points. And this example is marked with an O and it's a dashed line that's connecting them. So again, these are all connected. These are all the signs you can use to mark a data point. So you have a circle, a plus sign, an asterisk, point, cross, horizontal line, vertical line, all different kinds of options here. The reason that this is helpful, here are some other types. see some examples. This one is helpful, changing the line width. Let's go ahead and do that now, make it easier to see. So let's do just a dash line. We'll change the line width. You do that by typing line width, like this, and then the number, the width of the line you want. So here's 3. All right, so here's the example. It's a little easier to see for you, thicker. Okay. Again, you can kind of get into the details. Okay, I want to change the inside of the marker color, whatever. Lots of things you can do. The reason that we would want to do this kind of thing is in the case that we want to plot 2 things at the same time. So in order to plot 2 things at the same time, there are a couple ways we could do it. So one way would be to say, hold on. So we have one plot open like this, and we type hold on, and press enter. And then we type what it is that we want to plot. So let's say we want to plot sine of x now instead of cosine of x. And for this, we want it to be green. And we also want line width three. So here we've added a green line that's sine of x. Okay, so that's one way to do it. After you do that, then you would say hold off. Okay, so if I were to say plot again, it's going to remove everything and just start over. Okay, but if I say hold on, I can plot again, and it's just going to add. It's going to add to what I already have. So let's say I want to add a little phase delay. So sine of x plus 0.4, and we'll make this red with just red dotted line. Okay, so anything I add is going to just go on top of this. So that is one way to do it. The other way to do it would be something like this. So let's recreate our Linspace. Linspace. We had 0, 2 times pi, and 100. And we'll call this y1. So y1, we want to say is cosine of x. y2, we want to say is cosine, well, we'll say sine of x. And let's say y3 is tangent of x. What we can do now is say plot x comma y, and then we can just add x, y2, and then x, y3. Oops, should be y1. Okay, so notice here we have all of those here, and it just automatically selected different colors. Just selected different colors. Now, let me go ahead and create a new script. And type these things in. So x is linspace 0, 2, 2 pi, 100. I see a hand raised. What is it? Go ahead. Was there a question? I thought I saw a hand raised. Okay, I'll go ahead and move on. If you remember your question, feel free to raise your hand again. Okay, so again, we're going to say x, y1. Now, instead of just letting it do what it wants to do, we're going to tell MATLAB how we want it to plot it. So we'll say we want it to be a red line with line width 3. Now we're going to put a comma, an ellipsis. I like to put the ellipsis and just go to the next line. It makes it clearer in my mind, but you don't have to. So you could just keep this up here. I'm going to put the ellipsis and go back down. So y2, and we'll say this one is green, and we want a dotted line. Line width of 3. And then the last one, y3, and we'll just leave it as blue and say line width is equal to 3. All right, so let's run this. First, it's going to prompt us to save. We'll call this script 3. Okay. Yeah, I think I may have. Let's just ignore the color control for now. Okay, so I'll leave the okay, so one thing you'll notice about this is the height of the tangent, we know that tangent of, what is it, pi over 2 is, so it approaches infinity to the left of pi over 2 and approaches infinity to the right of pi over 2. Same for 3 pi over 2. So what's going on here is that we have a data point for tangent at 1.523. That's really high, 20.99 over here at 4.697. That's really high, 63.02. Let's say, okay, we don't care to sort of see that whole shape because, you know, we're missing the shape of sine and cosine here. So what we can do is add what's called an x limit and a y limit. So we'll type let y limit. Let me make sure of this command actually. Yeah, okay. So it's y lim. And we're going to set it from the minimum value, -1, to the maximum value that we want to see. Okay, so notice these are in brackets here. I'll press run. All right, and we see it there. Okay. Now, let's say this is really confusing. So we want to add a, oh, I see a hand. Go ahead. What's the question?
Doctor, could you repeat it, please?
Repeat
Why?
what part?
Why them?
Why limb? Yeah,
Yeah, it's
sure.
useful for what?
Yeah, good question. So here, let's say, we don't really care to see what's going on with tangent right there. Really, the view that we want to have is something more like this. Oops. Something more like this. Okay, where it's kind of from -1 to 1. That's the view that we want. MATLAB's going to automatically adjust so that you can see all of the data points. But let's say we don't care to see that those really high values. We know that it's high. We mostly want to see the sine and cosine here. So we can manually change the lower and upper values that are being displayed, the limits on the y-axis. To do that, we use the function ylim. What are the limits of y? Okay, and we set them inside by using square brackets, the lower value, so -1, and the upper value, +1. So when I press run, you can see the lower value is -1 and the higher value is 1. Okay, does that make sense? Does that answer your question? I will take that as a yes. Okay, so because these are confusing, we don't know what the colors mean. Is the blue cosine? Is the red cosine? Is the yellow cosine? What we can do is add a legend. So for the legend, we're going to add labels, just like we did for the X and Y axis. So remember, we had X label, X, Y label, Y, and title. We could say geometry. Now, we want to add a legend. So we're going to use 3 different labels, one for each line. The first one we use will go with X and Y1 because it's first. So remember, X and Y1 was cosine. We're going to put a comma, and then the label that goes with X and Y2, which is sine. And then the label that goes with X and Y3, which is tangent. Close parentheses. Okay, so now you see here the labels. It's saying the blue line means cosine, the red line means sine, and the yellow line means tangent. Okay, one other thing that I want to show you before I split you up into breakout rooms and give you an assignment to work on together in teams is how to show multiple plots in one figure. So what you'll notice here is that this figure is called figure 1. Figure 1. We could create a new figure by typing figure, open close parentheses. Okay, a new figure comes up. So that's figure 2. Figure 1 is still open. But here we have figure 2. So after we have figure 2 open, we can type plot X, Y2. Sorry, that showed up in figure 1 because I clicked on figure 1. Okay, yeah, okay. Great. So, sorry, whatever figure is, yes, I'll repeat. So whatever figure is active, that's the one it's going to plot to. So I've clicked on figure 2 most recently, going to plot X, Y, 2. Okay, it shows up there. If I have figure 1 open, plot X, Y, 3, it's going to plot on figure 1. Whatever one is open or the most recent, that's what we're going to plot to. So these are different figures, okay? Just take note of what they're called, figures. If I can control that manually, so I say figure 1. Okay, so figure 1 comes up. And then I could say plot X, Y, 2. Then I could say figure 2, plot X, Y, 3. So I'm controlling which figure the plot goes to by first loading that figure. But let's say that we want plots all in the same figure, but not in the same plot. What we could do, that may sound confusing, you'll understand once I type it out. What we'll use is a function called subplot. The inputs to subplot are the height, the number of plots you want in the height direction, and the number of plots you want in the width direction. So let's say we want 3 in the height and 1 in the width, and then we want to plot in the first position, and then we're going to write our plot, okay? So here we're going to plot them individually, X, Y1, X, Y2, and X, Y3. But in order to put these in different subplots in different locations, we need to say, okay, same size, but put it in location 2. Then for the third one, I say I want to put it same size, 3 by 1, but in the third position. So let's press run and see what happens. Okay, so what should happen is figure 1 comes up and it's going to plot what we had plotted before. So this is figure 1 right here. Figure 1. Then figure 2 is going to come up, and in the first position of a 3 by 1, it's going to plot Y1. So that's what we have here. The first position of a 3 by 1 is going to plot X1, Y1. Then onto the second position, Y2. Then onto the third position, Y3. So we don't have to do that in the same order. We could change this to position 3 or position 2, okay? Or it doesn't have to be 3 by 1, it could be 1 by 3, but all of these should be the same. 1 by 3. Here, now, if I press run, they won't be vertical, but they will be horizontal. Okay, because the number of rows comes first and then the number of columns. Okay, you could do 2 by 2, you could do 4 by 6, however many plots you want to have, you can put in there. So we could say 2 by 2. Okay, so this is position 1, position 2, position 3, and we just didn't put anything in position 4. We could say subplot 2, 2, position 4, and then add this. Okay, notice when I did the X label and the Y label, it went only on that plot. It didn't go to all the plots. only to the one that I added it to. If I wanted to add X labels and Y labels to these others, I would have to put it underneath the one corresponding to each of them. Any questions about this? Okay. Now what I'm going to do is give you an assignment that we'll work on for the next 30 minutes. So I will give you actually, let's say 20 to 25 minutes to work on it in breakout groups. I'm going to put you in the breakout groups. And then the last 10 minutes of class of this workshop will come together and I will solve it for you. Okay, so let me give you the problem. I'm going to describe what I want to see here. So let's, I don't want to draw anymore. Okay, well, I guess I can do this. So let's say that we want to see, oops, okay, I want to see a 2x2 plot that looks like this. Two by two plot. Here, I want to go from 0 to 1 on the x-axis, 0 to 1, actually for all of these. We didn't talk about doing an x-axis limit, but it's basically the same as the y limit, except you type x lim instead of y lim. Okay, and here I want you to plot e raised to the x. Okay. Now in MATLAB, when you do e raised to the x, you type, there's a function for that. It's exp. Okay, let me see. You're gonna need this. So where is insert? Whatever, I'll type it here. It's like this. Exp of x. Okay, this is a function for doing an exponential. So exp of x. Now, that's what I want here. In the second one, I want an approximation of e raised to the x. So it's going to look roughly the same, but a little bit different. Okay, so for that approximation of e to the x, I want you to use this formula. The approximation is this. Y equals, okay, it's a long formula. I'm going to type it here, then I'll copy and paste it for you, okay? Or at least a picture of it. It's 1 minus 3 times x over 5 plus 3 times x squared over 20 minus x cubed over 60. By the way, this is like that. All over 1 plus 2 times x over 5 plus x squared over so you can kind of see it a little better. I'll do it like this. Okay, I'm going to copy this and put it in the chat for you. Okay. So that's what I want to see here. This is the approximation of e to the x, e to the x. In the third box, I want you to combine them. I want to see e to the x, which is from here, and the approximation. Okay, I don't even know what the approximation looks like actually, but it'll look a little bit different. Might be a little higher, might be a little lower. I'm not sure. Then here, I want to see the error. And the error is the distance or the difference between each of these points. The difference between each of those points. So I want 0 here. And so basically the error might look something like this. Okay, so in this case, it actually wouldn't look like that. So it's a positive error. So it would look something like this. Okay, if this is 0 here. Okay, it's positive. So this line here is higher than what it should be. So that's why it's a positive error. Okay, are there any questions about what I want to see? I also want to see all of the axes labeled and titles on everything, and I want to see a legend here. Any questions about that before you go work on it in Teams? Oops, I just realized for some reason I didn't send that to everyone. Okay, so there is the approximation. You know what I want. Now I'm going to break out into teams. Just have to remember how to do that. So I'm going to go ahead and pause the share. Okay, we have 88 participants. We'll say four people per team. So we'll say 22 breakout rooms. Okay, and I'm going to assign these automatically. So you're not going to have a choice. What I want you to do is for someone to write the code. Okay, someone write the code and share it with all of your teammates. Okay, so here I will go ahead and enter the breakout rooms. And I will see you back here. I'll end the breakout rooms at 5:20. Ready, go. Hey, so I guess I was assigned to your breakout room, but I will not be participating. So someone else can go ahead and share their screen, and you guys can work on it together. All right, everyone. So let's go ahead and I will show you how to solve the problem. So just a reminder, this is the kind of plot we're trying to get. And I am going to go ahead and copy this and get started over here. So I'm going to write it in a script, clear, close all, CLC, always a good way to start a script. Okay, I'm going to use an X of, again, Linspace, and I'll go from 0 to 1, and I'm going to use just 100 points. Great, and then, so our Y1, I'm going to say is EXP of
Doctor?
X. Yes, go ahead.
We cannot see your screen.
Thanks. Okay, you see that here? Thanks for letting me know. Okay, so we have, again, clear, close all CLC. X is Linspace from 0 to 1. This is because I want to plot from 0 to 1, 100 points. And then Y1, which is the one I want in the top left, is EXP of X. Y2 is this. Okay, so this is, I just copied and pasted this. I'll put the ellipsis so we can see it all. Okay. Great. So now we want to open a new figure and do a subplot. And the subplot we want is 2 by 2, and now we're going to plot in the first position. And I want to plot X and Y1. I'm going to give the X a label. We'll call it X. And the Y label, we'll call it EXP. Actually, we'll do E raised to the X. And then we'll give it a title. And we'll say this is the actual value. Now we're going to move on to subplot 2. So this will be 2 by 2, location 2. And we'll plot X and Y2. X label, we'll call it, again, X. And Y label, we will call it approximated. Well, actually, we'll call it, we should call it this, but we're not going to do that. We'll just call it Y2. It's too long. And the title, we'll say, is approximated value. Then we will go to subplot 2, 2, position 3. And this time we'll plot both of them. So plot X, Y1, and X, Y2. X label, X, Y label, Y, title, combined. And then we're going to add a legend.
Doctor,
The first one, yes, go ahead.
in the plot, you wrote Y instead of X.
Thank you. So the legend will be E to the X, and then approximation. And then the subplot, let's go ahead and see this, make sure it's working. So we'll call this script 4. Okay, line 50, no, line 7. Okay. When we use the exponent with a vector, we need to include this dot exponent. Okay, dot exponent. If it's just a single value like 4 raised to the 2, that's fine. But if we have 4, 5, 6 raised to the 2, we can't do that because it's trying to do matrix operations. So we need to use the dot 2, and then it treats them individually. Okay, so that's what the error was for. That's kind of complicated. Just remember, if you want to do each individual element, you just use the dot. Okay, let's press run again. Okay, so here we have e to the x. I'm not seeing the approximation, so let's check what it is. Y2, okay. Why is it doing that? Okay. Let me make sure I have this equation right, because that does not look like a very good approximation, does it? Sorry. The approximation is of e to the negative x. So e to the negative x, easy change, easy enough. Okay, there we go. Okay, so we have the actual value here, e to the negative x. What I want you to notice here in the, right here, e to the negative x, so the y label, these are actually superscripts. So MATLAB can do that. You see the superscripts, they're actually smaller letters there. So how it can do it is before each letter in the superscript, you just type this caret. So caret negative caret x, and it's going to make both of them superscript. Same here with this label, e to the superscript x. I did that here, e to the superscript x, but it's actually negative x. Okay. Now, what you'll notice here is that both of them are here, but the approximation is so good that you can't really see the difference. Okay, so what we need to do, if we zoom in really close, we can begin to see the difference. Okay, so you can see the difference there. There is, in fact, a difference. So what we'll do, remember in subplot 2 to position 4, we're plotting the difference. So here we're going to plot the difference y1 minus y2. And we're going to do that for x. So x is the x values, and then y1 minus y2 are the y values. And then x label is x. Our y label is difference, or we'll call it error. Title. Real value minus approximation. So let's run it. Okay, so here we go. We can see the error. Notice here that the units is really small. So the error at 0 is pretty close to 0. The error at 1, for example, is 6 point something times 10 to the negative 5. Okay, so it's quite a small value there. But you do see that the error is increasing the further away it gets from 0. even though, you can hardly tell the difference over here. Okay, that was a whirlwind. That was very fast through the example. I'll take your questions. Are there any questions about this? About plotting and what we just did? Yes, I will send the file. Let me just go ahead and send it right here. What is this script? I thought it was script 4. No. It's Untitled 3. Okay, I will send Untitled 3. Okay, the recording of this lecture, Dr. Sarah, of the previous lecture, Dr. Sarah has. I will send this lecture to her, and I'll ask her if she can just go ahead and send the links to both of these to you. She has some means of communicating with you. So she'll send the link to both recordings. Okay. Any other questions? All right. Yes, thank you for attending. Hopefully it's helpful. And I will see you next week, same time, 4 to 5:30. Bye-bye.